Hello, good day. I be to Dr. Kumail. So today I will be presenting the elucidation of compounds focusing on both neutral and acidic compounds. So my name is Nayli, and through this presentation I will guide through various tests and analyze that led to the identification of specific compounds. So let's get started. So here's is an overview of what I'll cover today. The first one is the physical appearance of the compounds, the Lysan test for the presence of halogen, sulfur, and nitrogen, functional group tests, and spectroscopy analysis including IR and NMR spectra. Finally, I'll introduce the proposed neutral and basic compounds. So let's dive into the details. So we began by observing the physical appearance of the neutral compound, which provided essential preliminary information about the compound. So the first one we go through the color. The neutral compound was white and it appeared as a crystalline solid indicating a well-organized molecular structure. The odor of the compounds is sweet vanilla-like aroma, maybe a clue pointed toward a compound like vanillin, we don't know, and the melting point that we get is around 79 to 81 degrees Celsius, which just slightly different towards the literature melting point, which is 81 to 83 degrees Celsius. So it means that consisting with the melting point of vanillin. So next, we move to the Lysin test, which is the qualitative analysis method used to detect elements such as halogens, sulfur, and nitrogen in organic compounds. It involves fusing the organic compound with sodium metal to form water-soluble sodium salt. The salts are then subjected to specific tests, which is the three of the nitrogen, sulfur, and halogens. So we go to the first one, which is the nitrogen test. What we get here is the observation of pale yellow solution form, which indicates the negative results, which means that nitrogen is absent. The second one is the sulfur test. No black precipitate form for the observation, and this means that in also negative results, which sulfur is absent in this compound. And the last one is the halogen test. Also, no precipitate form, and also indicates the negative results for halogen tests. And halogen is absent for this compound. Next, we go to functional group test, which is also crucial for pinpointing the chemical characteristics of a compound. So, for the neutral compound, the first thing first, we perform the potassium permanganate test. What we observe is the purple color turn to brown, which indicates that our compound is unsaturated carbon. Also, the same results when we go through the sulfonation test. What we observe is actually our compound is soluble in sulfuric acid and yellow solution form. The third one is we go through the iron trichloride test and we observe the blue solution form. This indicates the positive results for the presence of the hydroxyl. The next one is the bromine water test. And by observing the bromine water not decolorized, we can suggest that this is the negative results, and it means that the hydroxyl is absent, but this data is rejected by relying on the IR spectrum and the positive results of the iron trichloride test. The next one is the Brady's test. By observing the red precipitate form, also for the Fehming's test, and the same observation we observe. Both of these show us the positive results of the presence for the carbonyl group. So the infrared spectrum was analyzed to identify the bonds present in the neutral compound. The key peaks included the first one is a broad peak around 3,200 to 3,600 per centimeter, indicating an OH stretch typical of hydroxyl groups. Next one is a strong peak near 1,680 to 1,740 per centimeter, suggesting a C1O stretch from an aldehyde group. And the last key peaks is additional peaks in the regions of 2,800 to 3,100 per centimeter, corresponding to CA stretch in the aromatic ring and aldehyde group. And the other peaks that we can observe here is at the regions of 1,000 200 to 1000 to 300 per centimeter, which indicates the CO stretching of the methoxy. And the last one is around that region also, we can see the redundant of the CO stretch of the phenol that attached to the base. The proton NMR spectrum provided detailed information into the chemical environment of hydrogen atoms. For the natural compound, a singlet at around 9 to 10 ppm indicated the aldehyde proton. Then the multiples in the regions from 6 to 8 ppm were consistent with aromatic protons, confirming the presence of a benzene ring. And then should be a singlet around 3 to 4 ppm suggested a methoxy group attached to the aromatic ring. And what we can be observed here is a broad singlet consistent at 6 something ppm indicated the hydroxyl proton. Should be the hydroxyl proton will be appeared at 1 to 5, but maybe this is a shifting at this spectrum, so we just accept it as a hydroxyl since it is a broad singlet. So, based on our analysis, the natural compound was identified as 4-hydroxy-3-methoxybenzaldehyde, commonly known as vanillin. So, this conclusion was supported by the data from the test and also the spectrum, IR and NMR spectrum, which match the known properties of vanillin. So next, we analyze the physical appearance of the acidic compound. What we can observe here is the color of the acidic compound is yellowish green, and it was a crystalline solid, reflecting the stability of and aromaticity in its molecular structure. It has a sweet smell, showing us that maybe it is a carboxylic acid functional groups there, and the melting point is very different from the literature review, so we deduce that maybe there is an impurities in this acidic compound because of the maybe extraction or other steps. So for the Lysan test, we go through three tests, which is nitrogen test, sulfur test, and the halogen test. And the result of the nitrogen test is negative results, which is the absence of nitrogen. The observation that we got is the pale yellow solution form, and the sulfur test, we also get the negative result, indicating that the absence of the sulfur as well. What we observe is no black precipitate form, and the last one is the halogen test. And the observation that we got is no precipitate form as well, and suggesting that the negative results also for the halogens. So we come across to the functional group test. The first test that we did is the carboxylic acid test, which is the reaction of carboxylic acid with sodium bicarbonate solution, and it produced effervescence due to the release of carbon dioxide. This confirmed the presence of carboxylic acid group, and it is a positive results. And the second one is the esterification of the carboxylic acid. The observation that we got is a fruity smell observed after pour into Na2CO3, and we got also the positive results indicating the carboxylic acid is present. Next, we go to the IR spectrum for the acidic compound. So what we can observe here is a broad peak around 2500 to 3300 per centimeter, characteristic of hydroxy stretching or heat stretching in carboxylic acids. Next is a sharp peak at approximately 1700 per centimeter, indicating the presence of C-O stretch in the carboxylic acid group. Aromatic C-C stretching appeared at as medium intensity peak around 100 800 per centimeter. And the next is the peak around 1200 per centimeter to 100 500 per centimeter, which indicating that the CO stretching, which suggesting the carboxylic acid group. And the last one is the CH stretching around 2800 to 3000 per centimeter. And we assume that the peak of the metal redundant with the peak of C-O OH peak, which indicating the carboxylic acid group. The proton NMR spectrum of the acidic compound reveal the first one is a broad singlet around 10 to 12 ppm indicative of the acidic proton in the carboxylic acid group. The second one is multiplets between 7 to 8 ppm corresponding to aromatic protons, and the last one is a singlet near to 2 to 3 ppm consistent with a methyl group directly attached with the benzene ring. So from the combined results of the test and also the spectroscopic analysis, we identified the acidic compound as 3-methyl benzoic acid, also known as amytolic acid. I think that's all for me. Thank you. So, in summary, we successfully elucidated the structures of both neutral and acidic compounds. The neutral compound was identified as vanillin, while the acidic compound was identified as amytanoic acid. Each test and analysis played a vital role in reaching these conclusions. Thank you for the attention. I think that's it from me. Thank you.